Well, thank you for joining the Continental Power Corporation PowerWorx Clean Power System presentation. Hi, my name is Alan Johnston. I'm the Chief Technical Officer for Continental Power. I am a graduate of Purdue University in electrical engineering, and I have spent a number of years in the defense industry as a test engineering manager and electrical designer, as well as 10 years in a direct selling company as VP of Manufacturing and the Chief Technology Officer. And it's really exciting for me to be able to bring you information about this very unique and beneficial system for just about every electrical distribution system. First of all, a little bit about Continental Power. We are a power conditioning system manufacturer and, I might add, developer. We help our customers protect their facilities. That includes their equipment. It helps to reduce damaging noise, and it manages their energy costs by reducing actual electrical use. And we go so far as to guarantee that fact in writing. The electrical savings component of the PowerWorx Clean Power System is custom designed, and it's integrated into your existing facility, providing you with electrical savings and protection for the entire property. Secondly, it is turnkey. It requires absolutely no shutdown of your operations. It can be integrated into a panel. It does attach through a separate dedicated breaker or ties in through a fused disconnect. So no need to turn off a panel and to shut down any operations whatsoever. The benefits of the Clean Power System, well, they're many. First of all, in terms of energy savings, in reducing electric bills, we actually reduce the kilowatt-hour energy charges. We reduce kW demand charges. We eliminate power factor penalties. Now, many electrical engineers will point out the third one on the list there, the elimination of power factor penalties. And any time that you increase power factor, that's a given. But we'll show a little bit later on how we reduce the kilowatt-hour energy charges and the kW demand charges. So if there are no power factor penalties for a given commercial facility, that's not an issue. We can still help to reduce the electric bill. And then for end-use equipment, and this is probably, in my opinion, even more important than reducing electrical costs from the utility, is the fact that we provide 100% downline lightning and surge protection. So not only from external sources, but internally generated sources as well. We reduce noise and harmonics in the electrical wiring. We improve productivity of personnel and equipment by reducing electric faults. When equipment goes down less frequently, productivity is increased. We reduce maintenance cost, and we increase the life of electronics, of the motors in the facility, of the lighting in the facility, and the transformers as well. Literally everything connected to the electrical distribution system is protected, has less damaging noise flowing through it, and therefore increased life. The Continental Power purpose and mission is, in regards to the PowerWorx line of products, they exist to reduce energy costs while at the same time preventing and solving power quality problems. The PowerWorx line of products meet customer requirements by, first of all, adhering to industry best practices, by providing state-of-the-art power conditioning, by providing systems at costs well below typical power conditioning technologies, and achieving a typical return on investment between 2 and 3 years, sometimes even less. Some of the contributors to high energy costs, and this is something that's good to be aware of. First of all, old infrastructure. A lot of old buildings with old wiring, old panels, old transformers. All of that contributes to higher energy costs. Secondly, increased electric demand. As more and more equipment is added into a facility, the demand goes up, sometimes exceeding the load carrying capacity of the distribution system. Thirdly, power factor tariffs in some markets are increasing costs from a few percent to over 35%. And in most cases, it's hidden in the electric bill. We find many customers that we enlighten with the fact where we show them that they are paying a penalty because their power factor is below the threshold set by the utility. This is sometimes very surprising, and it's easy to be able to reduce those costs. Then related power costs, those are rising continuously. Utilities, fuel, and operating costs are going up, so they have to pass it on to their customers. Reduced performance from power distortions. As the performance of the equipment goes down, because the power quality goes down, electrical costs go up. And then repairs and replacements for equipment. That applies to motors and components and drives. It applies to sensitive electronics like computer equipment. And then the related lost productivity that goes with it. All of this contributes to increased costs, not necessarily just costs on the electric bill. So let's take a look first off at what is a power quality problem. According to Dranitz BMI, it's any occurrence manifested in voltage, current, or frequency deviations that result in failure or misoperation of end-use equipment. So it's not just a disruption of voltage. It can be a disruption in the way that the voltage is being used, and it would therefore manifest itself in current. Or it can distort the frequency and cause deviations. So it's a whole host of things that we have to be aware of to understand why we have power quality problems. Some facts about the Continental Power Corporation. We have been providing power conditioning systems for over 16 years now. There are literally thousands of commercial installations that have been performed. Units installed in 1993, still in use today, have a 20-year plus expected life. There are over 50,000 residential units sold in the last 2 years. Customer satisfaction is really what is most important to us. It's the hallmark of the Continental Power legacy. It is a privately held company. It's headquartered in Greensburg, Pennsylvania, with manufacturing in Nashville, Tennessee, and I might add the sales and support office in Jonesboro, Tennessee. The manufacturing office is located in Nashville, Tennessee. It's a company by the name of Bonitron Incorporated, which was founded in 1992, and it's an electronics and electrical system design, engineering, and manufacturing company specializing in solutions and options for AC drives. Bonitron produces products which include braking choppers, resistor, line regens, power sag and outage ride-through systems, power supplies, and additional power conditioning accessories. Now, some of that may not mean anything to you, but I can tell you that Bonitron has worked with some of the top companies in the world, in many countries around the world as well. These are Fortune 50 companies that spend millions of dollars to improve power quality and ensure that there is no interruption in power, and Bonitron helps them to accomplish this. There could be no better manufacturing partner for Continental Power than Bonitron, and we're very pleased to have them as part of our team. PowerwoRx, the clean power system, has 3 unique capabilities, unique in the marketplace. These 3 capabilities are not unique in themselves. Each one has been around for decades, actually more than half a century. But what is unique is the way that we apply them, the way that we integrate them together. Those 3 capabilities are surge and spike protection, also known as transient voltage surge suppression, or TVSS. Noise reduction, including harmonic reduction, and then a reduction for reactive current, or power factor correction. And this is the component Well, along with noise reduction that can lead to energy savings. First of all, we provide surge and spike protection. We are now going to talk about the surge and spike protection that is provided by the Continental PowerWorx product. You know, if we look at the types of causes of surges and spikes, of course the most normal is lightning. There in the picture in the upper right hand corner. That's the thought that comes to mind, but there are a number of causes. Normal utility operations where you have a switching station, substation down the road that they're switching between transformers. Poor and loose connections, neighboring businesses that have high loads and they turn them on and off. That can cause surges and spikes. And then within your facility itself, corrosion, device switching, static discharge, arcing, all of those things can cause that. In a residential environment, even just a heat pump turning on and off, especially when it turns off, when that relay opens up, it's not at all uncommon for a surge or a spike to be generated as those contacts come apart. Did you know that in the state of Florida, it's considered the lightning capital of the U.S. by the way. They experienced over 300,000 lightning strikes in 2002 alone. The electricity flowing within a typical lightning bolt can reach 2 million volts. Electrical storms cause literally billions of dollars in property damage every year, and power surges are one of the main causes of damage to air conditioning systems. The PowerWorx Clean Power System provides 100% downline lightning and surge protection. It is a total protection system. You know, today in the city of Dallas, the PowerWorx is recommended by a local utility there as a good solution for every home to have to provide protection against lightning and other types of surge generation. Transient voltage surges and spikes affect facilities in many ways. First of all, poor performance. Electronic equipment can operate erratically. Computers lock up or you lose data, produce garbled results. Electronic devices may operate at decreased efficiencies. You get flat-out device failure. You know, most of the time we attribute these failures to old age of equipment, but if that equipment had the protection of the PowerWorx unit on it, it would outlast those that are unprotected. There's no question about that, because electronic components may not fail immediately, but you have latent damage, and that latent damage over time will add up and cause premature failure. How does the spikes affect facilities in other ways? Well, motors is a big one. Surges and spikes interrupts normal timing. It creates vibration and noise, and that creates excessive heat. Insulation of the windings deteriorate and then fail. Losses in motor functions that increase the amount of current necessary to operate the motor. Now you take the flip side of that, clean power, like what the PowerWorx is able to provide, reduces the amount of current necessary to operate a motor. And so we see just from this that we do get potentially some savings from ridding the facility of surges and spikes. We see effects on lighting, fluorescence system, early failure of not only bulbs but ballasts. Incandescent lights, we've all seen that, where you'll get a flash where you can tell the voltage has gone up, the light gets bright, and then all of a sudden, poof, the bulb goes out. So it definitely affects lighting. Electrical distribution equipment. Most people don't think about this, but degrading contact surfaces of switches and circuit breakers. Nuisance tripping can be attributable to transient activity. And breakers, they heat up and they cause them to actually react to a non-existent current demand. Operational inefficiency, losses produced by transients can cause equipment to run hotter than normal in the same way that we've talked about with motors. The solution is the PowerwoRx, and the PowerwoRx has built in within it industrial metal oxide varistors, or MOVs for short, to provide electrical surge protection, or better known as transient voltage surge suppression, or the acronym TVSS. I've got an article shown on the screen there from an IEEE magazine, Transactions on Industrial Applications, Volume 43, Number 1, from back in 2007, titled Electrical Surge Protection Devices for Industrial Facilities, a tutorial review. And taking just one sentence out of that, I want you to make note. It says, for this reason, MOV, or metal oxide varistor-based SPD, surge protection devices, systems are considered to be the most effective protection technology for industrial applications. And let me tell you, if it's the most effective technology for industrial, you couldn't get anything better to use for like commercial or residential. MOVs are the best technology available today, and the PowerwoRx has industrial rated MOVs within the product. Metal oxide varistors, think of it this way. It's like an electronic switch. It's extremely fast. I use the analogy of a sentry, a guard, who is standing by the panel, literally with his hand on the panel monitoring the voltage. And when the voltage goes above the level that is set for the MOV, that sentry flips a switch, and that switch will connect that power line to the ground line. And so all the energy that is above that preset level ends up getting diverted off to ground. It becomes the lowest impedance path. So these devices have to be able to source huge amounts of current. If we look at our commercial PowerwoRx units, they're rated up to 120,000 amps over an extremely short period of time, though. Keep that in mind. The turn on is at approximately 150% of the rated voltage, and it sends all that energy to ground. And then once the voltage drops below that threshold, the switch turns back off. Now, it is possible, especially in the event of a lightning strike close by, that the amount of energy that the MOV is having to source to ground is so great, and the current is so great, that although the MOV will accomplish the task, it will actually give up its life. It will destroy itself in the process. And we'll get to the warranty on our product at the end of this presentation, but I'll just clue you in right now that our product has a 10-year warranty, and that warranty covers where the product actually sacrifices itself. In other words, it's doing its job. There was nothing wrong with the product, but Continental Power still replaces the product anytime that were to happen over the full 10-year warranty of the product. That's a pretty amazing, something that I don't know of other products that do the same. Now let's take a look at the second feature that the PowerwoRx has within it. We reduce surges and spikes. We secondarily reduce noise. Now, a very common form of noise in electrical distribution systems is called harmonics. These are unuseful frequencies of energy you pay for, which apply reverse torque to motors. They provide no motor force. They disrupt electronic performance. They overheat components and neutral conductors. You'll typically, when you have noise and harmonics in the system, you will see the current in the neutral conductor go up significantly. It does damage motors. It damages electronics. It damages circuit breakers, and transformers. A lot of the same things that surges and spikes do, harmonics do as well. Now in the diagram in the upper right hand corner, you see in the dotted line the typical AC waveform, a nice smooth sine wave is what it's called. And then you see this small, what looks like a ripple out right through the middle line. And that is a fifth harmonic that is being put back on the line thanks to something called 6-pulse drives. We'll talk about that in a moment. When you combine the two waveforms, that small ripple in the middle and the nice clean dotted line AC waveform, what you see is the result there on the screen, something that looks like a camel's back, a distorted AC waveform. That is called total harmonic distortion, and how badly it's distorted will increase the percentage of total harmonic distortion, or THD. And that's something that is, again, is damaging. It's something that most industrial facilities today face because of the use of these high efficiency electronic drive packs that drive motors and use less electricity, but they do put these harmonics onto the line. We see those noise and harmonics generators almost everywhere. I just showed you the variable frequency drive result, but things like CFLs or compact fluorescent lamps, these are devices that the U.S. government is encouraging, maybe more than encouraging, pretty much demanding that consumers use in place of incandescent lamps, and I understand why. They use much less electricity, but they generate huge amounts of noise because of the switching power supplies, the power supply that drives the actual fluorescent portion of the lamp. Switching power supplies, they're also called non-linear power supplies, are small, they're very inexpensive, they are very cost effective because they not only are inexpensive to build but inexpensive to use. In every way they are much better than linear power supplies, which uses a typical transformer and a few discrete components. But the problem with it is that it does generate noise on the line because the power is being used in a very non-linear way. It creates, it's either on or off, and using an SCR or a triac, and consequently that generates lots of noise. And as I state here, the problem will continue to get worse as time goes on. More and more switching power supplies are being used. Virtually every single device plugged in today has some kind of an electronic controller which uses switching power supplies. So this will get worse. Applying power factor correction in a harmonic environment. Well, one of the things that we're going to talk about in the next section is reducing reactive energy using power factor correction capacitors. And where you place power factor correction capacitors in a harmonic environment, there is a real potential for problems. Modern capacitors are reliable, maintenance-free, inexpensive source of the VARs, volt amp reactive energy needed for inductive circuits. We'll talk about that in a minute. And for nearly a century, capacitors have been used to provide these VARs that are needed for inductive circuits so that we don't have to supply all of that energy from the utility. It's been straightforward. Literally, electricians only needed to know what the kW was or kVA, and you could size what was needed. The problem today is we have a lot of solid-state controllers, switching power supplies. These devices represent nonlinear impedance, and consequently these capacitors can get into an overcurrent condition. It can set up a resonance between the capacitor and these drive circuits. So adding capacitors can actually create more of a problem than if you didn't. A capacitor is not a noise reduction device. It exacerbates the problem. One of the key benefits of the PowerWorx is combining surge and spike protection, noise reduction, along with capacitance. We're able to not only not increase the noise levels, but we will decrease them. We have specialized types of capacitors that are harmonic resistant, so we can solve the problem and still provide the benefits of power factor correction. PowerWorx uses industrial filters to reduce total harmonic distortion. As I mentioned, harmonic resistive capacitors to mitigate the risk of harmonic resonance. And then also noise levels can typically be reduced anywhere from 50 to 90%. So a facility, as we're working on right now, where they have a large computer center this computer center is used for the entire corporation. They have multiple buildings on the property, but in this particular building, all the computers and all the power supplies that are driving the computer equipment and the drives and all the peripherals that go with it generates huge amounts of noise. Lots of current on the neutral, total harmonic distortion between 3 and 4%. We're able to put our units in there and reduce that distortion, give cleaner power for those computers to run on, and solve a real world problem for this particular company. Okay, the third benefit that the PowerWorx provide is reducing reactive current, or amps. This is called power factor correction. Now, what is power factor? Well, in a typical electric circuit, there is a time delay between when the voltage pushes the electrical current and when that electrical current actually begins to flow. The duration of the delay is the power factor. Now, I know that doesn't mean anything to you, but we're going to get into some practical applications here that this might become a lot more clear. To describe it some other ways, power factor is one efficiency measurement of electric power as it is transmitted over power lines and it is processed by end-use consumers. In other words, as it is utilized. Power factor is a factor of voltage, current, time, and phase angle. The closer the voltage-current relationship, the more power can be transmitted over existing conductors. Slightly below 1, which would be lagging, is better than above 1.0 or leading. Now, looking at that diagram, you see the voltage, the dotted line, is showing where the voltage begins, and you see it's peaked right at the dotted line and it starts to go down. You look at the current, well, the current doesn't peak until farther to the right or a short time later. The difference between the peaks, that measurement of time, is how we calculate power factor. And there are instruments that do it very well. As long as we can clamp around the conductors and get a current measurement and clip on to the voltage and the power line and the neutral, or if it's a three-phase system between power lines, we can get an accurate power factor measurement. Now, some terminology that you'll want to you may not pick up right now, but you'll want to look back on this and try and wrap your arms around it. There are three terms when we talk about power factor. First is real or active power. Now, it's somewhat really untrue in that when we talk about real and imaginary power, there's no such thing as imaginary power, but real power is measured in kW. It is what we say in electrical engineering terms. It's the working power. It's doing the work for the system. It actually is the thing that produces motion, torque, heat. Reactive power is measured in kilovolt amps reactive. It does not do useful work, but it is just as necessary. Its main purpose is to sustain the electromagnetic field. And then we have something called apparent power, and that's in kVA. It's working and reactive power together, and this makes up the apparent power. Now, a utility has a generator and it's producing kVA. It doesn't produce kW, and it doesn't produce kVAR. It produces kVA. But we break the two out because it is possible to remove the kVAR from the responsibility of the utility providing it, and to have the kVAR as something that is captured and supplied back to the devices that require it. There's a diagram that the U.S. government, the U.S. Department of Energy, put together. It's a 4-page document entitled Reducing Power Factor Cost. And I hope this helps you understand. It certainly did for me, to understand exactly what power factor is all about. It uses a great analogy here of a mid-1800s railroad switching yard. You would have railroad cars, and it was very common to pull these cars around the yard using a horse. Now, ideally, you'd want to have the horse pulling right in front of the railroad car. But unfortunately, with railroad ties and the unevenness on the track, the norm was to have the horse walk next to the railroad track. So the horse was pulling at an angle. Now, if you think about that, if you were trying to pull something, it's not very efficient to pull at an angle. You always want to be pulling straight on. Well, the same applies to electrical power. The most efficient use of electrical power is to have 100% of it working real power. Even the motors prefer to have it that way. When you have all your power as working power, you have a power factor of 1, and the total apparent power and the kW, the working real power, are the same, and there would be no non-working or reactive power. But most systems have some reactive power, so from an electrical standpoint, we're always pulling off to the side. The way we calculate, if we use some real-world numbers here, the real power of 100 kW, reactive power again is measured in kVAR, and the apparent power is measured in kilovolt amps, or kVA. In this example, the real power is 100 kW, and the kVAR is also 100. If you take those two lines geometrically, you can quickly calculate that the apparent power is 142. You use the power factor formula of real power of 100 kW over the apparent power of 142 kVA, and we get the power factor of 0.7, or 70%. And this indicates that only 70% of the current provided by the electrical utility is being actually used to produce useful work. Now, let's take this into a practical application. First, we need to talk about motors. Inductive loads, which include motors, cause this time delay between the voltage and the current. And the reason is, well, motors use current in two ways. First, we have something called magnetizing current. I bring you over to the right-hand side of the screen where we have the diagram, the AC waveform going in, and we have an electrical diagram of a motor. And current is flowing through two ways. One, it's flowing through the magnetic windings, creating this magnetic field, and secondly, it's flowing through the armature, and that current is actually doing the real work. That's what we call the load current. And the more work that the motor has to do, the more load that is on the shaft, the more load current that flows. The magnetizing current always stays constant. No matter what the load is, you're always going to have the same amount. So very seldom, if we have a constant load that's running 24/7 in a facility, your kVAR amount will always remain constant. The kW, though, can fluctuate, and that's fairly common. Power factor is therefore a measure of the efficient use of power. Perfect power factor uses 100% of the energy for load current, none of it for magnetizing current. And that's something we can do. Now, I said that we have to have magnetizing current. You can't get away from it. The key is that we have a way that we can take the current that's flowing, store it, and supply it to the motor when it needs it. And that's where power factor correction comes in. Okay, we're going to use a neat analogy that I don't know exactly who came up with this. This sounds like something that a professor, in trying to get his point across to his students in college, used. Um, it's called the beer analogy. And think of it this way. A beer mug, we think about capacity. That particular beer mug is 16 ounces. Well, inside of that mug, if you were to put beer into it, you're going to have some beer and you're going to have some foam, unless your bartender is very good about making sure that the beer is 100% and he allows the foam to run off. But that's not the norm. There's always a little bit of foam, and of course, in terms of value, the foam doesn't do anything. If you think of it even in terms of a soda, you always get some foam on the top of a soda, and ideally whoever's serving it will be nice and allow that to settle and fill it up some more. But it's wasted space, what we call, in terms of electrical terms, wasted capacity. Well, in our analogy here, the foam is equal to the reactive power. What is not doing useful work? It's the mug capacity itself is the apparent power, or the total capacity in kVA, and the beer is the real power. It's what the person's paying their money for. That's the kW. Power factor would be beer over mug capacity. Now, if your beer was 16 ounces and your mug is 16 ounces, you'd have a perfect power factor of 1. If you had, as we used in the previous analogy, 100, the kW for beer, and the mug capacity was 144, then you would have a power factor equal to 70%. Here's what's really fascinating about all of this. Capacitors provide the foam, the kVAR, needed to free up mug capacity so you don't have to buy a bigger mug. And so you can also pay less for your beer or whatever your beverage is. So we can free up capacity, that's one benefit. We also don't have to pay for the kVAR coming from the utility. Now let's take a look at this from a real-world example. In the upper left you see a picture of what's called a switchgear. This is a three-phase typical large main distribution panel in a commercial facility. And we have, in this example, a 125 horsepower three-phase AC motor. If you look in the bottom left, you see what that motor requires. Remember, we talked about the various terms. 125 kVA, that's our apparent power. 100 kW, that's our working power. And 75 kVAR, which is our reactive power, or useless power maybe. That's the power that's needed to magnetize the windings. Now, we have a PowerWorks there. This is a 50 kVAR Continental Power PowerWorks unit, which provides power factor correction amongst surge and spike protection and noise filtration. If we close the switch there above the PowerWorks, all of a sudden the reactive energy that is needed by the motor begins to flow from the PowerWorks unit. Not 100% of it, but in this case it would be 2/3 of it. So once the switch is thrown, instead of the switchgear and the utility feeding energy through the meter, instead of providing 125 kVA, we are now only asking for 103 kVA. Still 100 kW because the utility has to supply the working power, but the kVAR now drops to 25 instead of 75. Now you say, wow, you dropped the kVAR by 2/3, but you dropped the kVA by a lot more than 2/3. Well, if you notice that, you're absolutely right. This is a geometric relationship. Take a look in the bottom right-hand corner of your screen, and you'll see what I'm talking about. Without the PowerWorks engaged, you see the numbers there, 125 kVA, 75 kVAR, and 100 kW. When we drop the kVAR from 75 to 25, we increase the power factor significantly, and now that vector for the kVA is much, much shorter. Now it's 103 kVA instead of 125. Look in the upper right-hand corner, we see the beer mug analogy. Here is the resulting reduction in kVA and amperage. With no capacitor, we have the foam at the top, that's shown in red, versus orange at the bottom, where what you call the beer part of the analogy. With a capacitor, we do away with the foam, all but just 3 kVA worth. And by far 97% of what is in the mug is beer, and only 3% is foam then. There's a couple of things that I want to point out here. One is we never have to add as much kVAR is being used in the system. Our goal is to get the power factor up to around 95 to 97%. It's been written about many times by electrical engineers, authors that write in the IEEE journal, that bringing the power factor up to unity, or 100%, is a waste of money, because we're able to, with just providing 2/3 of the capacitance in this example, bring the power factor up high enough where we have very, very little reactive energy. And this is also a benefit if some of the motors in the facility are turned off. You won't put the facility into a leading condition that way. To describe power factor in simple terms, the PowerWorks stores the reactive power, the kVAR, needed to sustain the electromagnetic force, also known as EMF, within the inductive load. It provides the reactive current so we can magnetize the windings. As the motor operates, this reactive power is pulled and pushed to and from the PowerWorks by the motor. So the capacitors in the PowerWorks supply the motor with the reactive energy it needs. When the AC waveform starts going negative, the motor is giving up that current, and it's at the exact time that the capacitor needs it. So there's this pushing and pulling between capacitors and the motors, and ultimately we say, if you want to think of it this way, we recycle the wasted power, and therefore it's not needed to be supplied by the utility. The amount of reactive power provided by the utility or electric company has therefore been greatly reduced, or in some cases totally eliminated. And here is the key. When current, which is measured in amps, are reduced, energy dollars are saved. Now, there are going to be some electrical engineers, just like me, who said, wait a minute, I know when you reduce power factor, improve power factor, you reduce power factor penalties, and that's where you get your savings. I know when I was at Purdue, we were taught that improving power factor does not save on kW or kilowatt hours. Well, it may not be a direct relationship, but indirectly it absolutely does, and we'll get into that here in a moment. To restate it another way, for those who say power factor improvement only saves on power factor penalties and will not reduce the electric bill, the simple answer: reducing amps reduces kilowatt hour consumption. Let me state that again. Reducing amps reduces kilowatt hour consumption. By placing PowerWorks inside the facility, we reduce consumption by improving the efficiency of the electrical distribution system. And that's key. Underline in your mind the word efficiency. We improve the efficiency of the electrical distribution system. And it's not a single magic bullet. It's a whole series of small savings. If we take a look at those small savings, just by reducing current, we reduce losses, which provide quantifiable savings in kilowatt hours and reductions in kW demand. And here's a list of savings for each type of loss. Proximity effect losses. This is from inductive coupling. These are for those that are electrical engineers. You've, I'm sure, gone through this before. Even electricians know about these terms. If you don't, not to worry. But there are a number of electrical concepts here that this plays into. So if you have two wires in close proximity, there's inductive coupling, 1.5 to 3% losses from that. Line losses. This is due to resistance. Just like an electric heater that has a coil in it that heats up, that electric coil has a small resistance in it. But when the current flows through that, that wire heats up. Well, every foot of copper wire has a slight amount of resistance. When you add miles and miles of wire in a typical industrial facility, those miles of wire end up in total up to a lot of resistance, and there are losses. Not huge, but again, 1.5 to 3%. Hysteresis losses from armature rotation, 2 to 5%. Transformer losses. You know, when you have a 480 volt main supply and you have a 480 to 208 volt transformer inside a commercial facility, those are not 100% efficient. Some are 95, some are 90, some are as low as 80% efficient, depending upon the type of transformer and the age. So transformer losses can total up to 1 to 2%. Switching losses, this is resistance through relays, through breakers. Again, there's a small amount of resistance through that contact, 1 to 2%. So you add all these up, not one of them is significant, but you add them up and you can see where you can get 5, 6, 7, 8, 10% even savings just by reducing current within the facility. So how much energy is available to be better utilized? Well, a typical office environment can attribute 40% of its energy load to HVAC alone. According to the U.S. Department of Energy, the U.S. spends 50 to 65% of its energy on motor loads. And these are all the devices that we're able to help reduce reactive current for. So, you know, we have energy savings features listed here, as well as where the PowerWorx is able to save. In some cases it's restoration, in some cases it's avoidance. But voltage balancing, when you have a panel that's way out of balance, there are certainly energy losses that are associated with that. Voltage balancing is very important. Demand reductions, that's a preventative savings. Power factor correction, we just went through that, 0 to 20%. Harmonic balancing, Department of Energy says 0 to 8%. So there's a number of factors here. We at Continental Power are very, very conservative. We've had many customers that have received savings that are well above 20%. But when we go in and present a proposal to a customer, you'll see numbers in the 4 to 8% range, showing a return on investment typically of that 2 to 3 years. And what we usually find is the customer gets much better results than what we've guaranteed, but we would rather be conservative and over-deliver and under-promise, because there are a number of variables, variations in the electric bill, and we would much rather see the customer get a much nicer savings than what we've even guaranteed. Okay, the PowerWorx improves the efficiency of the electrical distribution system. You know, we've talked about that a little bit. I want to make sure you understand this point. It increases the voltage at the load, and the reason is that we're getting rid of line losses. It increases production and the efficiency of the operation. Voltage losses can wreak havoc on an industrial, any type of facility. It doesn't even have to be commercial. Residential, the same problem. But when you get into an industrial facility where you have very, very high currents, voltage losses can be significant. It can actually stop the equipment from properly operating. We've seen it many times. But here's the key. By reducing current in the lines and current traveling through transformers and switches, PowerWorx allows additional load to be serviced without adding additional capacity. And this has been one of the reasons that PowerWorx has been sold over these 16 years many, many times. Maybe not the majority of the time, but certainly a very high percentage, because the facility is out of capacity. They have a 2,000 or a 5,000 amp service, and they're going to need to add more manufacturing equipment, and they have maxed out their service capacity. The transformer can only handle so much kVA, and they've exceeded that or getting close to exceeding that, and they want to add more equipment. Now they have two choices. They can go in and upgrade their service, oftentimes costing $30,000 to well over $100,000. They can add another service, so they have a second service at that point. That again is likewise very costly. Or they can go in and reduce the kVA being drawn from the existing loads. Where there is a poor power factor, we can reduce the current significantly, freeing up the kVA that is needed coming from that transformer. So this is one of the big benefits of the PowerWorks system. Some general information I want to share with you. These are maintenance-free products. They're solid-state devices. There's no moving parts. It's not meant to be opened. It's not needed to be opened or serviced during the operating life. The product has a 10-year warranty and a 20-year useful life. It is recognized by UL Laboratories in the Industrial Control Equipment category, and it has both UL US and UL Canadian certification. Why use the PowerWorks system? Well, first of all, guaranteed savings. When we go into a large commercial facility, typically of 80,000 or more thousand kilowatt hours, 80,000 or more kilowatt hours per month, we'll put a proposal together and specify the amount of equipment, typically 3 or more units, to be able to properly treat that facility. And we'll list the guaranteed savings, we'll list the return on investment in months, and that proposal is a turnkey system. It includes installation, it includes engineering work. We actually send an engineer to the facility typically to do a walkthrough and identify the proper location for all the units. It is an integrated power quality solution. It provides 100% downline lightning and surge protection, power factor correction, and noise reduction. We've gone through those things in detail. It's a system solution which exceeds the capabilities of individual technologies installed independently. This is a very important point. You know, we have had customers who have installed surge suppressors, who have installed noise reduction devices, who have installed power factor correction capacitors, all on the same panel, who did not solve their problem, but when we came in with a PowerWorks unit and put it on that same panel, after taking those other 3 devices off, we were able to solve it. One of the biggest customers of Continental Power is AMF Bowling. AMF produces bowling equipment, is the largest supplier in the world for this. Well, when they went through their transition from manual scoring to automated scoring, they experienced some major challenges with their scoring equipment, problems with boards failing, and their engineers worked very hard to try and resolve this problem using all 3 of those devices, unsuccessfully though. PowerWorks was installed. From that point forward, they did not have another failure. Today, AMF Bowling ships a PowerWorks unit with every 10 lanes that it sells. Now, this isn't for energy savings. It's to make sure their equipment works better for their customer. They're not paying the electric bills. So although the customer will get a little bit of a benefit from the energy savings, their concern is that when their equipment goes out, that their customer, the owner of the bowling lanes, his center works properly. So the synergy between these 3 technologies inside this box are greater than the sum of the 3 parts that have gone into it. Our intellectual property is not capacitors and MOVs and filters. The intellectual property is the way these are integrated together inside of the unit. The clean power system performs significantly more functions than capacitors, and unlike power factor correction capacitor solutions can be operated in noisy environments. We've talked about the risk of capacitors when there are harmonics that are in the system going into a resonant condition. You don't have to worry about that with the PowerWorx when it's properly installed. And there is really no known genuine competitors in either performance or customer assurances that are provided by Continental Power. As far as implementing the PowerWorx solution, typical requirement is 1 unit per 40,000 kilowatt hours of monthly electrical use. A large grocery store may use 400,000 kilowatt hours a month, which means we would most likely put in 10 of our units put throughout the facility. We generally put 1 at the main distribution panel, and the remainder go deep into the facility so that we can reduce the currents throughout the facility. Return on investment is typically 2 to 3 years. Using a 4-year lease, now this is really interesting. If using a 4-year lease, and we have leasing companies that are thrilled to lease money to customers on this equipment because they know that it works, they know that it's going to save them money, they know that the savings will pay for 100% of the lease payment. And get this, and return money back to the purchaser. Now, here's what it's like. It's like us coming to the customer and saying, we've got this product, we want to give it to you at no cost, and on top of it, we're going to come back to you every month and write you a check for the next 4 years, and then at the end of 4 years, we're going to increase that check by double. That's in essence what we're talking about here. Using a lease, net equipment cost is 0, and dollars are returned to the customer. Net savings over a 10-year warranty period, typically 300 to 600%. And the ROI does not include, that's just electric bill savings now, folks. ROI does not include increased equipment life, reduced maintenance, reduced equipment downtime, increased electrical distribution system capacity that we've talked about, that $30,000 to $100,000 plus modification if they're out of capacity, and then the reduced risk of catastrophic failure from surge and spike. We have got a customer in Pennsylvania by the name of Davis Cookie. Davis Cookie manufactures cookies, and they sit in a position where they are very susceptible to lightning, and they had 2 instances where their whole system was knocked offline, damage was done to equipment, the cookie processing line shut down, and it took time to get their system back online. Every bit of the dough that was in process had to be removed, thrown away, the whole system sterilized. The system was down for 2 to 3 days going through this process. Several years ago, Mr. Davis had our systems installed in his plant. They have had lightning strikes close by. They have had huge surges come through. In fact, our Continental PowerWorx commercial unit has been damaged from one of those surges that came through. But it stopped the surge there. The only damage done was to our product. We brought it back. It was another unit was shipped out to Davis Cookie, and it is still operating to this day. Now, how much is that worth? Probably more than the 10-year warranty savings of 300 to 600% in terms of return on investment. Think about all these benefits that are here that aren't included in that ROI. So, site selection. If we're looking for facilities that make sense, well, things that we look for. What has the lowest power factor in tariff markets? So in other words, in markets that charge a power factor penalty, what facilities have poor power factor? What has high energy costs? Kilowatt hour charges of 10 cents per kWh, where they're high kilowatt hours per square foot. In other words, they use a lot of energy per square foot. We've seen warehouses that are immense, but all they have is lighting in them. No cooling, no real electrical loads. Maybe not the best usage or best potential customer. What's got the largest facility? And those facilities, you'd be looking for facilities with lots of motor, HVAC intensive by the amount of floor space they have. High ceilings if they're heating and cooling that. High power loads because of that. Which industries have power quality sensitivity requirements, such as computers, medical, AV production studios, precision manufacturing plants? And what facilities have maintenance frequency concerns, such as information technology, communications, point of sale systems? A lot of facilities have those. Restaurants, grocery stores, copiers, AC, machine tools. There are so many different facilities. I think in my experience, about 30% of the facilities we look at are not a good fit. They just don't utilize power in a very consistent way, or their power consumption is very low. If you look at the flip side of that, 70%, far more than half of all commercial facilities are a good fit. So it's great to have such a tremendous need for this product. So if we're going to get started, I'll ask a question. How soon do you want to save? Well, here's what we need. The customer provides 12 months of electric bills. Where KVAR is not on the electric bill, the utility is typically contacted for data. If not available, typically we try and put a meter on, a data acquisition meter. Fluke makes a meter that is especially useful for this, the Fluke 1735, and meter that facility for 1 week to get the information we need. Continental Power will develop a detailed power use analysis and a system solution. Once the proposal is accepted, an engineer from Continental travels to the facility for a site survey to determine installation locations. Installation is typically contracted through a local electrician, and as soon as the system is activated, the customer receives immediate savings, immediate benefits through efficiency and productivity, and then they'll be seeing the savings on their electric bill as well. I'm sure that you have questions, and hopefully we've got the answers for you. You can email us at info@continentalpowerworks.com. I encourage you to take a look at our website, continentalpowerworks.com, for more information as well. I hope you found this review helpful. We have a full team of engineers and account managers that are here to be able to help you with application questions, with whatever you might need. We look forward to hearing from you. Thanks for taking the time to listen to this presentation.